Hello, I'm Victoria McHale, and I'd like to take a few moments today to talk to you about welding gas safety. Specifically, I'm going to focus on two topics. The first is the required regular and routine leak testing of all hoses, regulators, torches, connections, and all pressurized lines and equipment for leak integrity of the system and to help assure safe operation. Secondly, I'll go over how to test a welding gas quick connector, as is required by virtually all equipment manufacturers. Over the next couple minutes, I will quickly go over some easy-to-follow steps to help everyone work towards a goal of achieving a higher level of workplace safety. This video is part of a series designed to help improve safety in the workplace. Please note the information contained in this video was obtained from sources believed to be reliable and is based on technical, regulatory, and experience currently available. It should not be assumed that every acceptable practice, test, or safety procedure or method, precaution, equipment, or device is shown, or that abnormal or unusual circumstances may not warrant or suggest further requirements or additional procedures. The equipment manufacturer's instructions, gas supplier's material safety data sheets, or MSDS, as well as important information listed on the cylinder label or bulk gas system should be read and followed. Any leak, even one quite small, can have a disastrous consequence. All connections, not just those using flammable gases and oxygen, should be leak tested only by an approved leak test solution before being put into use. A few examples should help us define why we have to use a leak test and what an approved leak test solution is. According to ANSI ASC Z49.1, Safety in Welding and Cutting, Section 10.5.2.1, leak testing connection states, leak test solutions for use on oxygen connections are commercially available and are recommended. Both U.S. and Canadian regulatory agencies enforce ANSI ASC standards, and employers may be subject to fines and additional liability if ANSI ASC standards are not followed. Further, the standard states connections shall be checked for tightness after assembly and before lighting torch. Flames shall not be used. In addition, when using pressure-reducing regulators, the CGA connections or union nuts on regulators shall be inspected before use. Most manufacturers in their product instructions require, after installation, a purge of systems and testing of all connections and equipment for leakage with an oxygen-compatible leak test solution at maximum working pressure for the appropriate gas shown on the product. All connections must be clean and free of damage, oil, grease, and other unapproved lubricants. The question that is often asked is, why can't someone just use soapy water? The answer to that is one of the dangers in working with an oxy-fuel process is the potential for oxygen and hydrocarbon, oil and grease, to combine and cause an oxygen-enriched fire. Although oxygen itself is non-flammable, it does support combustion of flammable materials. The concern here is the spontaneous combustion and fuel fire that may result from the presence of oil, grease, or combustible dust around cylinders, valves, fuse plugs, and safety devices. Oil and grease in the presence of oxygen may ignite spontaneously and burn violently. Next, I'd like to talk about specifications that define what materials can and cannot be approved in the leak detection system. The MIL PFR 255567E specification is designed to establish the basic criteria necessary to ensure that a leak detection compound used in oxygen is safe. The specification addresses this concern in two ways: by specifically prohibiting certain materials that can be used in the formulation of oxygen-compatible leak detectors, and by having these leak detection compounds pass 9 performance tests. The materials that cannot be contained in the leak detection solution are mineral oil, vegetable oil, animal oil and fats, any material that will ignite or explode when in contact with liquid or gaseous oxygen, materials that will act as primary skin irritants, skin sensitizers, or produce any other dermatitis, as well as ketones, aldehydes, and alcohols as components in the formulations. Now I would like to talk to you about quick connectors. Quick connectors are designed to connect torches, torch handles, and equipment to hoses, or regulators to hoses or equipment for quick setup, change, or takedown of equipment. Quick Connect hose couplers come with a built-in automatic gas cutoff valve and meet the requirements of safety standards ISO 7289 and EN 561. They are designed to provide convenience and valuable time and cost savings. Quick connectors make setting up and taking down equipment faster and easier, increasing productivity and reducing theft of equipment. If, for example, you are switching from a brazing torch to a cutting torch, it's as easy as disconnecting your first torch and connecting the second torch in only a matter of seconds. You don't have to deal with taking out wrenches and going through the time-wasting and tedious task of unscrewing the hose from the first torch and then having to attach the second torch to the hoses. Just doing that once a day wastes valuable resources, and imagine what it wastes if it has to be done numerous times. How about at the beginning or end of the day or shift? If an employee is required to put away his torch or owns his own and takes it home when he leaves, they will not waste valuable production time because they can simply pop the torch on and off as easy as this. The same goes for the quick connects on the regulators. It makes it that quick and easy to take the hoses down, allowing them to be moved out of the way, and makes it easy to move the gas cylinders quickly. We now would like to demonstrate how to test quick connectors for leaks. Whether it is a torch model or a regulator model quick connector, they are tested under the same principles and it is easy to perform. First, we will demonstrate how to test the torch models. Please remember to always wear safety glasses and do not smoke. To begin, shut off the gases at the cylinder or line valve and safely vent the residual gases. Next, disconnect the torch from the hose by disconnecting the coupler from the pin. Then, visually inspect the pin for burrs, scratches, and/or deformation. If any of these conditions exist, replace the pin. Now submerge the outlet of the quick coupler socket onto the end of the hose and into a glass of water. Once the equipment is set up, reopen the cylinder or line valve and open the regulator and adjust the pressure to approximately 3 to 5 pounds per square inch